So, welcome back students. So, now we will be discussing another important strategies. At the very beginning we said that we are mainly focusing on 3 strategies in a parallel fashion. We said transformation based strategies, functional group based strategies and starting material based strategies are basically closely related and you cannot distinguish between them. Transformation we have covered and we said that there are key transformation which will give you an idea that which transformation you need to use it to access a desired target. Functional group we have already discussed in detail and particularly this functional group we have talked about skeletal disconnection, we have talked about synthetic equivalence, we talked about appendage disconnection, we talked about protecting group based disconnection and then we talked about redundant functionality. So, things have been covered. Now, starting material based is basically related to these strategies, but as I earlier also we talked about some cases we have given you a well defined starting material in a job is quite easy. So, in the starting material based strategies mainly we will try to figure it out. The starting material is given to you and a target was also given to you, then you try to formulate if there are multiple routes can be designed or can be traced back, so that a single starting material which is given to you can lead to a multiple pathway and you have to individually analyze which pathway is much more viable to you based on the step as well as the cost of the reagents and other things you have to take care. So, once your target is fixed and the starting material was given to you, starting precursor or the starting material. Now, this was basically the very old approaches, oldest approach and we will as earlier we will basically discussing the problems with a particular given target. Now, in this particular given target we will be just trying to analyze what are the possible retro for this given target molecule. This molecule is a natural product, this molecule's name is Valeranone. Valeranone is a C15 framework molecule, it is a sesquiterpenoid. You count its carbon, it will come as a C15. So, valeranone is a natural product and now initially we are not discussing the what starting material to start. We say that let us first do a conventional retrosynthetic pathway and if you can come to a more than one pathway, then we will analyze which pathway is better and then we follow the forward things. So, eventually initially the pathway which we say will be trying to have these groups are all there. The stereochemistry was kept, but in the retro pathway we will not discuss about the stereochemistry. We say initially if you can introduce this kind of ketone adjacent to this isopropyl group, probably a FGA is required. Now, this is basically redundant functionality. Okay. So, FGA based on redundant functionality we initially have devised. Then we say okay, if this can be done we will now do our next round of retro based on this kind of transformation. Now, here we are saying that we will be doing a functional group interconversion, or it is not a functional group interconversion, it is basically a transformation. It is a 1,4 Michael addition to a methyl nucleophile to this alpha beta unsaturated ketone system. Now, we will try to simplify it and now we are saying if you have this intermediate and a compound like this. Now, this retro is pretty interesting, and this retro basically will give you a favor of our earlier very well known retro or well known name reaction called Robinson annulation. Now, this Robinson annulation, what we say, initial step is Michael. So, this is Michael acceptor, this is a nucleophile. So, first it will be coming here. Now, these things will now generate a negative charge here. So, initial this Michael this initial Michael will takes place. So, this carbon carbon bond will be basically forming here. Now, you are having another COMe here. So, in reaction medium if you have a base, this can undergo aldol Michael reaction. So, try to formulate the mechanism which will allow this particular transformation. So, initially you get these things methyl. Okay. So, now this methyl will we have to extract a proton from this acidic methyl hydrogen, and that will undergo aldol reaction. So, basically have this aldol then, and which will then lead to the product, the Michael aldol adduct, and the structure is like this. Your methyl is remain here. Fine. So, this route looks quite viable. So, you are basically here. Now, that your next forward pathway is how you can selectively do some reaction here. Now, initially you have a saturated carbon, you have unsaturated carbon. Saturated carbon, I said, is highly reactive, you can protect this saturated carbon, do some protection here, do some protection here. Saturated carbon. So, I take this saturated carbon or this particular intermediate. Okay. And then I say saturated carbon, unsaturated carbon. So, do the protection here with ethylene glycol. All the remaining part will remain similar, methyl is here. Now, you do a methyl copper lithium, the Gilman, to introduce this methyl. So, just we are also talking about the forward pathway, which will help you how you can see the entire synthetic pathway. Methyl, methyl, your isoprolyl is here. Now, basically what you need, you just do a Wolff-Kishner type of reduction. So, Wolff-Kishner type of reduction will then deoxygenate this ketone, this methyl, methyl, and you have this. Now, you just remove the particular protecting group here to get the target molecule. So, this is your valeranone target molecule. So, the route 1, which is basically very nicely demonstrated, and we have absolutely no issue with this route. The similar way, you can have come to another route which will show that how a different target molecule, or a same target molecule, you can design different starting material based approaches, and how a single target can be disconnected through a different starting material. Now, I will be talking about route 2. Route 2, I say there might be another route, though this route is little bit unconventional, but still this is also possible. And I say if I have this kind of bicyclic compound, we will be doing a Michael addition here to introduce the methyl group in a methyl minus, okay. and then this will be generated enolate here, that will be trapped with a methyl electrophile, methyl iodide. So, looks logically possible, but then how you can make this compound? Now, for this compound your making was little bit looks like some this way. I said okay, we will be trying to give you a retro something like this. Now, what this retro basically says? This retro says if you can have a initial carbon ion generation here, that can give you this carbon carbon bond through a Michael addition. Okay. And once this Michael was done, you can close this thing through a aldol pathway, but actually this substrate itself was very tricky, because there are many carbonyl groups are there, and you will be basically having numerous acidic hydrogen which will be picked up by the base, and eventually self aldol condensation will be a big problem. So, this substrate will put a big question mark, big question mark. So, eventually in the similar pathway you can also think about another substrate which is also now let us will formulate. We will say this one also a relatively similar kind of pathway which also might be possible. How? This negative will generate to gives you this Michael pathway, and then you have this aldol pathway. Now, again I am saying this starting material is very dicey, because you are having too many carbonyl compounds in the compound, and all this will be basically leading to self condensation, and is very difficult to handle. These two substrates are very difficult to handle. That is why this route 2 will put a big question mark, though it is logically valid. So, this target, by using this starting material, it might give you the desired target, but we are absolutely not sure what will be the reaction yield, which will be now drawing or which will be now analyzing. You have a methyl, you have this iso thing. The next route which I am now giving, the first will be a functional group addition, and you say that the functional group addition will basically put you a OH here, the remaining groups are remain same. This OH you can basically create from or access from this epoxide. Assume that it is a FGI and a hydride will come from sterically less hindered site. There is hydride can come from here or hydride can come from there, but if hydride come from this site, this is more facile because sterically less hindered, this side is blocked, that is why this is not feasible. So, this route is quite feasible. Now, how to access this epoxide? How to access this epoxide? So, for this epoxide definitely you need a double bond, something like this, you need a double bond with these two methyl, fine. And then I say if you have this double bond, you can basically formulate another reaction which is our known Robinson annulation. Now, see this route, this particular transformation, how you can going to access it? We said that first we will put a methyl minus in 1,4 fashion to give you this CO and Me. Okay, we will discuss this pathway little bit later on. Now, if you can analyze this is gives you a very standard Robinson annulation pathway. So, it will basically give you this compound and your methyl vinyl ketone. So, now we try to analyze the route 3 and we see how this route 3 also is possible. So, route 3 we say you are using a methyl vinyl ketone and this cyclohexanone based compound. So, initially your Michael followed by aldol will basically give you this bicyclic enone, right. Next you need to introduce this angular methyl. So, do a Me2Cu Li mediated 1,4 addition and then see if you do a 1,4 addition basically come here. Now, the retro which was next drawn is basically you have to generate a olefin. If you can see the earlier piece of paper. So, now you have to reduce these things to lithium aluminum hydride and convert this alcohol to corresponding tosylate. So, now what intermediate you will be basically getting? You basically get intermediate this. Now, this compound is a tosylate and you heat it with triethylamine. Simple 1,2 elimination will takes place and basically you will be expecting the formation of 2 regioisomeric product, this one as well as this one methyl. Now, both the product might be formed in equal amount because you do not have a stability factor which can be counted that this product will be formed in excess. So, eventually this is the desired product, but you also have a regioisomer which may formed in 1:1 ratio. Now, once this product is formed, you go back to our earlier things, you take this product, do the epoxidation, LH opening and access the product. So, now in a summary we will try to now analyze all the routes. So, route 1, route 2 and route 3. So, route 1, what are the transformation we are using? Basically is a Robinson annulation is the main transformation, okay, and we also use couple of functional group addition or FGI and it looks absolutely feasible. Route 2, which was basically again based on a aldol Michael pathway, but this route is little bit dicey at the starting material which contains a multiple carbonyl groups. Route 3 also based on couple of FGI plus functional group addition and the key transformation is again the Robinson annulation. Though it looks feasible, but this route is having a regiochemical issue. Regiochemical issue means which regioisomer is forming. So, basically the desired regioisomer may not form in good yield. So, you have a yield related issue. So, based on the whole 3 different routes, I would rather prefer the route 1 which does not have any ambiguity. So, this route looks absolutely perfect because this route will allow you access of this desired target without any question. You can control the all the effective pathway, the reagents are pretty easy, the starting materials are pretty easy and throughout the entire pathway you do not have any regiochemistry issue which needs to be addressed and whether route 2 the starting material seems to be absolutely difficult to access. This is polycarbonyl compounds which can undergo self condensation reaction. Route 3 looks fine, but at the initial step when you are doing this elimination reaction, that will give you 2 residue isomers. So, that also a big problem associated with that route. So, in the starting material based approach, our main thing will be basically focused on how a target you can access with the help of the starting material which was given to you. Definitely this approach is similar with the earlier approaches. So, we will be basically trying to solve many problems as discussed earlier. The first one is very simple problem which was given to you. It is a dialdehyde. The starting material which I have given to you is a nitrile compound. Now, all of us know that nitrile can be converted to CHO, okay, that is for sure, but then you need to introduce another CH2 CHO group here. So, let us say first do this thing here. So, I will put a minus here and I say if you having a CH2 Br, if you having a bromoacetaldehyde, that can act as the electrophile and that basically can attack here. Now, it was a bit difficult because you are going to do a base mediated reaction. So, carbon ion is there, it can undergo aldol reaction, self aldol reaction, many things can take place. So, I will probably recommend this route is not feasible. Instead, you as the starting material was a nitrile, you take this starting material and then you find whether this CHO CH2 Br can be act as the electrophile. Okay, it looks promising, but eventually when you generate this carbon ion here, probably this carbon ion can undergo self aldol reaction with this electrophilic aldehyde, this aldehyde. So, this particular group how you can introduce BrCH2CHO, I say okay, let us try it other way. I say okay, let us put these things. Okay. Then if you can fuse a allyl group here, this allyl as a electrophile, then it looks quite possible. So, your intermediate, if the intermediate is having this structure, it looks absolutely fine. You need to just do a oxidative cleavage. So, now then go to the forward pathway, start with N-butyl CH2CN, treat with base LDA and treat with allyl bromide, okay. And then this allyl bromide react here to give you this alkylated product, So, here you straight away do the ozonolysis, and that will basically give you CHO. Now, we have a difficult situation because here now if you do a diol reduction, cyanide will be reduced, that is fine, but you also have this aldehyde, which will be also now reduced to the corresponding alcohol. So, ozonolysis you need to be very careful that which place you can use the ozonolysis. So, now here if you use so this route is discarded. So, now here if you do the diol fast, do the diol fast, that is fine. then you do the ozonolysis, then basically you are in perfect shape. Ozonolysis does not cause any disturbance to the corresponding aldehyde and you can fit here. So, as discussed earlier, you might have a 2 or 3 different possible routes, but you need to pick the best route which looks perfect according to the chemical logic. And then also in the earlier page we have talked about that you can think about using the bromoacetaldehyde as a electrophile, which in principle you can do it, but bromoacetaldehyde is very difficult to synthesize. On the contrary, if you use a allyl halide or allyl bromide, which is pretty easily available, and allyl bromide, allyl halide, you can simply clip this double bond to generate the CH2CHO. So, this is perfectly easily accessible and you can have a absolute control. So, we will try to continue our discussion on the topic which we have just started, starting material based strategies, and we will give you a target, we will give you a starting material, we will try to formulate whether there are many routes are possible or not. Then each and every steps, each and every routes we will analyze very closely and then we choose the best route which is suitable according to the chemical logic. So, okay, have a good time, see you in the next lecture.